welcome. Thank you for coming to my talk. And I want to dive into a topic that I feel that it's not talked about enough in our industry, which is the topic of web accessibility. First of all, let me introduce myself. I'm Leonardo. I'm from Venezuela, but I have been living in Chile for 5 years already. I work at Globant, which is an Argentinian-based company, but it has offices in Santiago. I'm part of the Mozilla Tech Speakers program. We can talk about it later because it's very interesting. Maybe you should all join if you're interested in speaking at conference. And you can follow me at almost any social network with that handle, Pancas87. So, what is accessibility and why is it important? First of all, you might see a lot this abbreviation, this acronym, ALMY or ALI. It's because accessibility is a mouthful. It's really hard to say. I get it wrong in English, in Spanish, like I say accesibilidad, and I get it wrong. I say accessibility, and so for short, we say ALI. But that it's like the least accessible acronym that there is in the world, because when a screen reader reads this, it's awful, it doesn't understand it, so it's kind of ironic. Okay, so first of all, why is accessibility important? The World Health Organization estimates that there are around 1 billion people in the world suffering some form of disability. It might be motor disability, it might be sensory disability, but it's around 15% of the population living with this. So it's quite a large number, so sorry, I'm a little nervous here. It's quite a large number, so we cannot ignore this. Even we have to think about ourselves in the future, because when we grow up, we will probably lose sight, we will probably lose coordination in our hands, like loss of reflex, loss of hearing. So if we don't take accessibility seriously, even us in the future will suffer. And the World Wide Web is still the most popular form of accessing the internet. And the internet is nowadays considered by many people, including me, a basic human right, because there are many things that only can happen online, even government stuff that you cannot do in physical offices anymore. So it's like blocking access for people to the street. It's like saying to someone, you cannot walk to the street. It's the same. It's like blocking access to a basic human right. And we are blocking access to job opportunities, education opportunities, to business, communications, everything. We are leaving a lot of people outside of amazing opportunities provided by the digital era. And we have to start thinking about it. It's our responsibility to fix this, because we have all the tools in our hands to create accessible websites. They exist. We have modern browsers with accessibility APIs. We have screen readers. We have many assistive technologies. So it's just negligence on our side that we're not doing it already, plain and simple. So it's our mission, if you ask me, to start building a more inclusive and accessible digital space for everyone, regardless of their economical background, regardless of their social background, their cultural background, their different range of abilities. Like you can have different range of cognitive abilities, sensory abilities, motor skills. So we have to think of all of this right away. And that's the main definition of accessibility, is creating digital spaces that are usable and understandable by the largest range of the population possible. We probably won't be able to get to everyone out there because there is a huge spectrum of abilities in the world, but we have to try and make it accessible for the largest portion of the people in the world. So we have to keep in mind that accessibility is not a job only for developers or only for UX designers. It is a multidisciplinary endeavor. So I'm going to ask all of you, what are your roles? For example, if you're a web developer, raise your hand. UX designer, content writer, product manager, or product owner, or whatever, project manager in that space. Okay, so all of us in here, we have a responsibility and we play a role in web accessibility. When we are designing web experiences, we are all responsible. It is not only the job of one or two people. It is like it involves all of us. So we are the main responsible for creating disabilities. Disability people don't suffer actually disabilities. We create disabilities because people have a specific functioning capacity. Like they can do this and they cannot do that. And when we create barriers, when we add obstacles, we are the main cause of a disability. People have a specific type of abilities. We add a barrier in our websites or in the physical world even. I have an example later. And we create that disability. This is a shift in the mindset that is proposed in this book called A Web for Everyone, Designing Accessible User Experiences. I recommend everyone to get this book and read it because it actually aims at this, at producing changes in the mindset of people. Like stop thinking like people with disabilities are at fault because it's not them, it's our fault that they cannot access our resources. And it's a good example that I found yesterday in Twitter. It's like, it's not the fault of the person who was in the wheelchair. It's the fault of the person who, knowing that they should build a ramp for people in wheelchairs, they didn't do it. It's the fault of the guys who built that street. So we have to keep that in mind. We are the main responsibles. And it's time to break down these barriers. Like I was saying before, we have all the tools in our hands, modern operating systems, modern browsers, and we can destroy these barriers. We can give people access to this amazing digital world that probably has changed the life of every single person in this room. The life of every single person in this room probably has been changed by technology. I know mine was. I probably wouldn't be where I am if it wasn't for technology. So we are depriving people with disabilities from these amazing opportunities that we ourselves have experienced. Now, how do we do it? Because it's very easy to come here and say, oh, you're responsible, you should do this, you should do that. Okay, but how do we do it? First, we have to start from the basis of the guidelines published by the World Wide Web Consortium, which published the Web Content Accessibility Guidelines, which are a set of technical criteria that websites should comply with and that should make them accessible. And these guidelines are organized under 4 foundational principles, which make up the acronym POWER. And this acronym, it's a summary that websites should be perceivable, operable, understandable, and robust for everyone. Like I was saying before, not only for people with the most common type of abilities, but for everyone. And these are the 4 foundational principles over which the guidelines are built. So let's start reviewing the principles one by one. Perceivable. This means that the websites we create should consider all the different ways that people with disabilities receive sensory information. Maybe some people cannot see, maybe some people cannot hear. So we have to account for that. And we have to provide alternatives for everyone. It's very popular, for example, for people who cannot see to use screen readers or to use braille displays to read what's on the screen, so we have to take that into account. But we also have to remind like maybe smaller or less, I don't know how to say it. Yeah, like less grave disabilities, like for example, people with color blindness, they can see, but for example, they might not be able to distinguish a a font color from the background because it doesn't have enough contrast, for example. And that's also something we have to think about. Or, for example, if we have multimedia content, we have to provide closed captions just like REFACTR is doing for people who cannot hear what I'm saying. Provide captioning for people who cannot hear our videos or audio files in our websites. So we have to start thinking like more of a 360-degree approach, like not just what I feel, what I perceive. No, we have to think of everyone and the way they perceive websites. Now let's talk about operability. What does this mean? Operable websites are websites that are created in a way that allows interaction through different input methods, regardless of the ability of the user. For example, we have to create websites that can be operated by keyboard, that can be operated by mouse, for example, there are people who use like one single switch for doing everything in their computer, or we have to think about people like Stephen Hawking, for example, who use like a really very specific set of commands to operate his computer. That's the kind of people we have to think about, people with very limited mobility. People with missing limbs, for example, or with degenerative diseases like Stephen Hawking had. And we have to make every functionality available through keyboard, through mouse, and through any other type of pointing device. Sorry. We also have to give users enough time to read and understand the content that we display, because, for example, we could be dealing with older people who might have slower reflexes, who might not read as fast, or we might be dealing with people with maybe ADHD, like I have, that maybe they lose focus and what you had was disappeared from the screen. Now they didn't read something important. We have to think of all of that. Now, understand all. It's the following principle. What does this mean? It means that websites allow a user to understand the information presented to them and the operation of the user interface and the mechanisms of how to operate this website. We have to think that it's not only enough to perceive something, you also have to understand it. For example, this picture I took it in the World of Coca-Cola, where they have like information brochures and they have it in every language, because okay, I can speak English, I can read English, but there could be someone who pick up a brochure in English, he perceives it, he reads the letters, but he cannot understand it. So we also have to think about that, and we have to use standard HTML techniques for language content, for example, adding the language tag, the language attribute to our HTML tag, use the data definition, data term, data list elements, or the abbreviation elements, so we can like expand the meaning of acronyms like A11Y, for example. It's a candidate for using the ABBR tag in HTML. So you can say, oh, A11Y actually means accessibility. That could be read by a screen reader, for example, and it could the person reading it or perceiving it could make sense out of that abbreviation. So it's very important to not only convey the information to the user, but make sure that he is able to understand it. And this also means taking into account different cognitive abilities. Like there are persons who are slower to understand written text. There are persons who have trouble understanding audio instructions. So, for example, when Google sends you a two-factor authentication message, you have the two choices. You can hear it or you can get an SMS, for example. That's very important because you have to give people the most available options that you can give them. And we have, like I said, we have to think about elder people as well, because they are not as fast maybe at understanding technology, for example. They didn't grow up with this, so this is a whole new world for them. And we should also help users correct mistakes. For example, when they're filling out a form, we should tell them what inputs fail and why did they fail, for example. That's part of making the experience more intuitive. And also we should make consistent UI elements. Because, for example, if you have a button that in one page behaves this way and in 2 pages down the road behaves other way, the user will get confused. Like, but when I click this button, a drop-down appears. Now when I click this same button, I don't know, a pop-up appears. It's like, it's inconsistent, and that also harms the understandability of our websites. That's an image from the book I was saying before. That's like a persona they created. That's a guy who has dyslexia. That's another thing we have to take into account. For example, there are even fonts that are special for people with dyslexia that helps them like not mix up the letters when they're reading. So it's like a wide array of different types of abilities that we have to take into account while developing our websites. And the final principle is the easiest one to comply with. It's the Robustness Principle. It states that websites can be operated with multiple user agents, browsers, assistive technologies, both current and in the future. But the easiest way to comply with this is using standard coding practices, like using a standard HTML. If we are using the Aria specification, respect all the standards, all the rules. That's fairly standard stuff that we should already be doing. Because if we're not, our website's markup is not valid, and that's really the easiest principle to comply with. So, as I was saying, the guidelines are technical implementation details. They tell us how to make websites accessible, and they are testable. All the guidelines criteria are testable, like in a Boolean way, like I am complying with this or I am not. Like I am providing captioning for my videos or I am not. And they're related to how implement web accessibility. Here, I'll share the slides with you later. Here are the World Wide Web Consortium specifications for the guidelines. And these guidelines have 3 conformance levels. The A level is the first one, is the easiest to achieve. And every criteria has these 3 levels defined. And you can choose which level to implement depending on the needs of your website, on the needs of your project. You might be running short on time and you have to release something. Maybe you won't make it to AA, but you try at least to make it to A. And then in a future iteration, you go and reach the AA level, which is a lot more demanding. Every step of the process is more demanding, and AAA is almost never achieved because it's very restrictive on designs, because visually it puts a lot of restrictions. So it's really, really hard to achieve it, and most legal requirements only demand that you get until AA, unless that you have like very specific needs. But that's the approach, for example, for remediation projects, like applications that already existed and you need to make them accessible. You start like, okay, I have 1 month to achieve the A conformance level, and then I have 6 months to get to AA. But when you get here, you are still opening up your application to a lot more of people that before could not use it. So it's still a success. Like if you don't make it here in the first run, you're still succeeding because you are making progress. You are opening up the possibilities for people. And the principles, the power principles, actually I prefer to focus on this because the principles are the foundation. Maybe you won't know all the guidelines by heart, like, oh, I can tell them in my sleep. It's really hard because there are many guidelines. But if you understand the principles, the core of this, once you start developing experiences for the future, you start thinking about how to make them accessible from scratch. Even if you don't remember the exact guideline, like 1.2.4, maybe you won't remember it, but you remember that the website has to have captioning for the videos. Or you remember that form controls have to have like feedback when there are errors in the validation of the form, for example. Maybe you won't remember exactly the number of the guideline, but you remember that it is a principle because that's the understandable principle. And for me, it's a lot more important to understand this, the core of the WCAG. And now let's talk about the accessibility tree. Sorry, accessibility. Like I said, it's a mouthful, this word. So, what is the accessibility tree? All operative systems have accessibility APIs that they use to expose to assistive technologies the graphical elements of the user interface in a way that these assistive technologies, like screen reader mostly, can understand it. And the browser has this builds an accessibility tree, which is very similar to the DOM, the document object model. It's a tree-like structure with a hierarchy that has like all the types of graphic interface elements that a website has. The browser takes the document object model and builds this accessibility tree and exposes it to the operative system. And that, for example, if you use NVDA or JAWS, what NVDA uses is actually the accessibility tree. It queries the browser like, what is the accessibility tree of this website? It gets a tree and it starts traversing it. That's how the assistive technologies interact with the browser. And it's the basis for building this accessibility tree is actually the DOM itself. So starting from the DOM and using the Aria specification, which we'll review later, the browser builds this and exposes it. This is an example of the accessibility developer tools incorporated into Mozilla Firefox, which actually lets you navigate through the accessibility tree. For example, here we have the Mozilla Developer Network documentation for accessibility. It's kind of like recursive. And this is a menu. And this here is marked as a list. So the accessibility tree exposed this menu as a list to NVDA or JAWS or any other screen reader. And in here we can consult, for example, the states. We will get into that later. Like this is a read-only list, it's selectable, it's enabled. It's basically information about all the graphic interface elements present in the website. And as I was saying, the basis of the accessibility tree is a DOM. That means that we have to be very careful about what we put in the DOM, because if we use semantic elements, we will have more than half of the work done. For example, if we use a button for its original purpose, if we use a text area for its purpose, but if we have like these websites that are full of divs and spans, that's awful for accessibility. Or if we have bad hierarchies in our heading tags, that's terrible because, for example, people with disabilities, sometimes what they do, for example, people who cannot see, they use a screen reader and they do pretty much the same that we do. They maybe check the table of contents. They have like a shortcut that reads them all the headings in the right order. So we have to have headings that are semantic, that are descriptive of the real content there. Then we have to use the correct form controls. We should not use like divs that with JavaScript we add the behavior of a button. No, you should use a button. Or we should not use a div that behaves like a text area. No, add a text area, because that way, natively, you will expose in your accessibility tree the interface elements in the way that was intended to be used. Like this is a checkbox, and the browser and the screen reader will understand what's the purpose, what's the expected behavior of this element. And also using the structural semantic elements like header, article, footer, because it also helps people who cannot see, it helps them a lot in navigating the structure. Like they can, like I said before, they use a lot of shortcuts to like skim the page, just like we do it visually. They do it with their hearing, but they have a lot of shortcuts to do the same. So we have to think of them and think about the semantics in our websites. It's like the most important. Let's try to see this example. This is a very good video of a guy, I think he's using NVDA, if I'm not wrong.
This is Mark Sutton from the University of California, San Francisco, IT Web Services Department. Here today with a brief tour of screen reading technology. I'm a blind person who has been using screen readers, braille writers, scanning equipment, other adaptive technologies since my childhood of these pages. So for example, I could just keep reading.
Down are 3 items. Visited, link, image, home.
Line by line, and we could be here all day. Or I could jump to the first heading on the page.
Heading level 2. Search for heading level 2. You are here. Heading level 1. Make videos accessible.
So as I'm moving down through the page, I can look for the category that interests me. And I'm just using commands built into the screen reader. So that's all a pretty simple description of what a screen reader is all about. Now I'm going to go over and show a few examples of how that can fall apart. So I have a couple graphics on this page.
Mark Sutton hands on the MacBook Pro image.
So the first one is well described and uses an alt tag.
You are current.
Well, I stop it because I think you got the general idea. This guy is using, I'm pretty sure it's NVDA, to navigate the page with shortcuts. Like I want to read the headings or I want to read the links. They even have like different modes. When they enter a form, the screen reader enters in a different mode, and the commands they use changes because they're in a form, and they have like more editing capabilities. So it's very, very important to respect semantics, because otherwise the screen reader won't understand what you are displaying to them, and they will have to read your whole page line by line, which is very tiresome. It's tiresome for us that we can see. Imagine for someone that has to hear it. It's very, very exhausting. So developing semantic websites solves more than 50% of the most common accessibility issues. Of course, there are things that we have to solve other ways. We'll see how. But semantics, like you should already be doing it. SEO is also, if you care about SEOs, about your position in search engines, you should be doing semantic coding as well, but there is now one more reason to do it. And when we need accessibility beyond semantics, we have the Aria specification, which is another standard developed by the World Wide Web Consortium that extends the accessibility features of native semantic web elements. It gives us basically 2 capabilities. First, to create more complex widgets than what the browser has natively. And second, we can, for example, add roles, like if we have this div I was talking about that we're using as a button, and changing it is really expensive because a lot of CSS and JavaScript are tied up to that element actually being a div and not a button, and we break everything if we change it to a button. We can add the role button. It's an Aria attribute. Aria is basically a set of attributes. It's all that it is. It's nothing more than that. And we can start adding these attributes to, like, Aria stands for Accessible Rich Internet Applications. So we make our applications actually richer. We give them more meaning, more behavior beyond the native browser behavior. So when should I use Aria? I should use it to define landmarks in our content, like header, footer, but only if it's a remediation project, like I said, because if you are starting from scratch, you should be using semantics. Although there are some additional landmarks that are not defined in the HTML specification, we will see them later. Also, we can use Aria for dynamic updates. For example, when we load something with Ajax and we update the page, we can use Aria attributes that inform the screen reader about that change in content. That's something that HTML doesn't do natively. We can enhance keyboard accessibility. For example, if we have this div that we're using as a button, we can give it focus by using the tab index attribute, for example. I'm sure many of you have done it before. That's part of the Aria recommendations. And we actually, when we use Aria, we gain more control over the accessibility tree, because unlike the DOM, we can manipulate the DOM. We can add elements, remove elements. We have complete control over what's there with JavaScript. But we cannot do the same with the accessibility tree. We cannot like modify it directly. And that's why we have to go through the Aria attributes, because the Aria attributes actually, they do affect the appearance of the accessibility tree. So that's our way of indirectly affecting the accessibility tree. And like I said, it's just a bunch of attributes. The main attributes are the roles. And you have many roles. For example, you can have widgets, composite roles, like for example, a combo box that has like a text box and a drop-down list or a menu. We have document structure, like I was saying, article list. And most of this, if you can see, they map one-to-one with semantic HTML elements. Usually when you use, for example, the button role or the list role or the form role, it's because you did something wrong and fixing it with the correct semantic element is way too expensive. And then you just add an attribute that will not affect your JavaScript, will not affect your CSS, and you just remediated the problem. But there are, like I said, many other things that are not native in HTML. For example, a slider, a progress bar, a combo box. What else? A search landmark, for example. A navigation, for example. If you started using like a div and changing it to a nav for some reason it's too expensive, you just add the role navigation and you're done. Live regions, like I said, that update based on changes in content. And when for example, if you use a live region and the content in there changes, the screen reader will notify the user that something actually happened. I have an example of that here. And in here you can have all these, there are these and there are many more, and they are all documented here in this link. And the states and properties, they apply over the roles. Like the roles are the components. It could be like very atomic components down to a button, or it could be like more organic or molecular components like combo boxes or even full regions of a website. All of these roles have states and properties. For example, you can have Aria check, Aria disabled, Aria expanded. Aria check applies, for example, to checkboxes and radio buttons. Or Aria expanded for collapsible elements. Aria expanded has a value of true or false, depending on whether a collapsible is open or closed, basically. Live region attributes, drag and drop, and relationship attributes. These are very important because they allow you to connect two components. For example, say that this component controls this another component. For example, this button controls this dropdown. Or the described by and labeled by. For example, we can have an input field, and we can say this input field is described by this another field. So when the user, he's using a screen reader, he's probably tabbing through the website, and once the focus is in that element, the screen reader will actually look at the Aria labeled or Aria described by, and we read whatever it's in that another element. So we can start connecting elements that visually might not be close or that might be in different parts of the DOM With this, we can have a little bit more of control over that. And this is an example of a widget, a tab panel, and how the screen reader actually behaves when changing this.
Selected use draw key plus alt plus M to move to controlled elements. 1 of 3. Representative tab selected use draw key plus alt plus M to move to controlled elements. 2 of 3. Chosen tab selected use draw key plus alt plus M to move to controlled elements. 3 of 3. Move to controlled elements. Tab panel. Chosen to fill others dot terms. Tab panel ends.
That's an example of a tab panel element, which has the 3 tab panels and like the place where the main content appears, and they are actually linked by, if I'm not wrong, by an area labeled by element or area described by element. That's how you make the relationship, and that's how the screen reader knows which of the parts that are hidden or shown actually is related to which of the tabs on the top. And basically, for me, the best analogy I can find for describing the accessibility tree and the Aria specification is that we use HTML semantics and the Aria specification to design the user experience for assistive technologies, just like we use CSS to design the visual experience of a website. It's pretty much the same. We are simply creating a new user experience for a different type of users that are using other abilities that are not the ones that we have, basically. And we have finally some testing tools. I wanted to give you like, maybe I could check one out, let's see. This one is really funny. Well, it's not funny, it's really cool, I don't know. Where is it? It's called No Coffee Vision Simulator. You can simulate different visual impairments, like, for example, degenerative diseases. And you can actually see a website the way that a person with some visual impediment will be looking at it. It's very eye-opening, no pun intended. It's very revealing because you actually get to see how other people actually experiences your websites, and you put yourself in the shoes of your users. This is one of the most interesting tools. Wait. But first, let's start with screen readers. This is the whole list of screen readers. The 3 most common are these 3 on the top: NVDA, JAWS, and VoiceOver. VoiceOver comes with Mac by default. NVDA is free and JAWS is paid. Chromebox is just a browser extension, and Orca is simply awful. Never have been able to use it successfully. These browser extensions are pretty cool. The Chrome DevTools have an accessibility audit, plus what I show you that comes natively in Firefox, the accessibility tree inspector. And the Axe and Wave are auditing tools that actually tell you about minor issues in minor accessibility issues, but keep in mind that these are not silver bullets. Like, they will only warn you about the easiest issues to fix. You will always need human criteria for this. Well, at least for now. I don't know in the future, machine learning and stuff. There are CLI tools that do the same. Like, they traverse your DOM and warn you about basic accessibility issues. You can, for example, put them in your CI tools and make the builds fail if you don't pass the accessibility test, for example. We do that at work. And finally, some very good learning resources I recommend. The first 2 are official from the World Wide Web Consortium. They are the Authoring Practice of Aria and the Web Content Accessibility Guidelines. Then the Mozilla Developer Network accessibility tutorials are really good, are really very easy to understand. And the World Wide Web Consortium accessibility introduction is also really, really, really good. So I recommend you all go and start learning accessibility. And I believe, since we are in Atlanta, I saw this quote by this guy from Atlanta. You might know him. He's kind of famous here and in the whole world. And it's an invitation to what I've been saying during my whole talk, to start thinking of other people, to start thinking about the needs of other people. So I'm going to close the talk with this very powerful quote that says, an individual has not started living until he can rise above the narrow confines of his individualistic concerns to the broader concerns of all humanity, which is a quote by a guy who was born here in Atlanta, Dr. Martin Luther King Jr., and it's very, very powerful because it's an invitation to start thinking about other people. Like, yeah, I can see, so this website is fine for me. Yeah, but it's not fine for 15% of the population, so we have to start thinking about that. And that will be all. We have like 2 minutes for questions.
You mentioned a tool that will cause your build to fail if it's not up to some standard. Can you go back to that? Is there one that you would recommend that the tool is, or?
I like Axe because it's developed by, I think it's DQ. It's a company that it's very involved in accessibility, so they are very good. But yeah, you can put it in your CI and the slides are available here.
Okay, thank you.
So sorry, I was a little nervous and maybe my pronunciation was not on top, but thank you for coming.